Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
What's it like to work in space? What does it take to be an astronaut? We're here at the Johnson Space Center to find out, and we'll answer your questions. Stay tuned. Science Trek is next. Hi, I'm Joan Cartan Hansen, and welcome to Science Trek, and welcome to the Johnson Space Center. We're here at Mission Control in Houston. Here, technicians and engineers spend 24 hours a day, 7 days a week, monitoring the International Space Station. Today, we're going to find out what it's like to work in space and learn more about the engineers and scientists who make it all happen. Later in the show, we're going to take a tour of some of the facilities here at the Johnson Space Center. But first, before we answer your questions, let's learn a little bit more. The word astronaut comes from the Greek words meaning sailor among the stars. Humans had long wondered what was beyond the Earth's atmosphere, but outer space was the great unknown. Still, scientists pushed, and by the late 1950s, both the Soviet Union and the United States were trying to be the first to put a human being into space. It was the height of the Cold War, and America's pride was at stake. But the first human to go into space was Yuri Gagarin, a Soviet cosmonaut, a member of the Russian space program. So American President John F. Kennedy challenged U.S. scientists to do the Soviets one better.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Alan Shepard was the first American in space.
Godspeed, John Glenn. 8, 7.
And John Glenn was the first American to orbit the Earth. They were part of the Mercury project. Apollo astronauts trained to go to the moon. Millions tuned in and watched Mission Control and the progress of these space explorers. And on July 20th, 1969, Americans Neil Armstrong and Buzz Aldrin were the first humans to set foot on the lunar surface.
That's one small step for man, one giant leap for mankind.
In 1971, Edgar Mitchell landed on the moon as part of the Apollo 14 mission. Years later, Mitchell appeared on the first show of this series and explained what the moon was like.
It's like very, very fine talcum powder, but it's made of basalt rock, or lava rock, that's been pummeled and ground up by billions of years of meteor impact to a very, very fine pumice. Now, what does it feel like to us to be on it? It's kind of like being on a trampoline where you can bounce up and down. The reduced gravity is very light and allows you to bounce, which accounts for the bunny hop that some of us use to locomote, or the long sloping strides that others would use. You do feel light. Even though we weighed 474 pounds Earth weight, on the moon it only felt like about 72 or 3 pounds.
It takes a lot of training to go into space. There are two kinds of astronauts, pilots and mission specialists. All American astronaut candidates should be U.S. citizens, have a college degree in engineering, biological sciences, physical sciences, or mathematics, have at least 3 years of experience in a STEM field or as a teacher. A master's and doctoral degree also help. Pilots have to have at least 1,000 hours of pilot-in-command time, and flight test experience is useful. All candidates have to be in good physical shape, have good eyesight, and good blood pressure, and they have to pass a rigorous physical exam. Astronaut candidates train for 2 years. There's time in the classroom, and they must complete military water and land survival training. They also have to learn to speak Russian, because now the International Space Station is a multinational cooperative effort. Once selected for a mission, astronauts have to learn more about how to work in space. They train at the Johnson Space Center in a mock-up of the International Space Station, other laboratories, or facilities in a giant swimming pool. They have to learn all aspects of their specific mission and how to survive in space. Fewer than 400 people have ever been selected for this job. But astronauts don't work alone. Thousands of other highly trained specialists play an important part in the space program. Many men and women work in mission control, which monitors and drives the International Space Station, and at the Johnson Space Center and other facilities around the world. There are astrophysicists, aerospace engineers, planetary scientists, communication specialists, and many other career opportunities. And as NASA looks toward Mars and other possible human space flights, who knows what new opportunities are ahead? You may be among the next to explore our universe and be a sailor among the stars. And joining me now to answer your questions about what it's like to be an astronaut are two NASA scientists. Dwayne Ross, Manager of Astronaut Candidate Selection and Training, and Amy Ross, a spacesuit engineer for NASA. Thank you both for joining us. Okay, let's go to your questions.
Hi, my name is Daniel. I go to Collister Elementary. My question is it cool to work in space?
It would be really cool to work in space. In space, when you're on something like the International Space Station going around the Earth, all you got to do is let go and you just kind of float around, and you can use your fingertips just to push from one side to the other. And to be able to look out the window and see the Earth and look out the other way and see all the stars, I can't think of anything to be more cool than working in space.
Hi, my name is Hannah. I'm from Illinois. I'm 8 years old, and my question is, how old do you have to be to go in space?
How old do you have to be to go to space is a good question, but it can vary. Now, right now, when you go into space, you have to have done a lot of things like go to college and complete a college degree in engineering or science or math. So the key thing for anybody who wants to go into space is to stay in school and do well, stay in school and do a lot of different things, you know, be involved in school activities and things like that, because we look for good, well-rounded people to send into space. But the range of age of people that we have selected to train to go into space has been between 26 and 46. So it's a pretty broad range. And we've sent folks into space as young as about 30 years old, but also as old as 70 years old. And so it's a really wide range. But the key thing is you got to be a few years old to have been able to get through school and get through college and get yourself a degree. So stay in school.
Hi, my name is Melanie, and I go to White Pine Elementary, and my question is, how do you eat in space?
So you eat in space very much like how you eat on the ground. The big difference is that you have to be very careful about how you get your food from your plate to your mouth. Because if you try to scoop it and shove it too fast, it can hit you in the face because it'll come flying off your spoon and hit you. So another difference is that we also try to have foods that don't crumble, because you don't want a bunch of crumbs floating around in your space station. So we have, instead of peanut butter sandwiches on bread, we use tortillas to put the peanut butter on.
Hi, my name is Chloe and I go to Hawaii Harbor Elementary, and I was wondering, how long do astronauts train before they can go into space?
Astronauts have to do a lot of training before they go into space. When they first come to work as an astronaut, there's a basic training program they have to go through to learn a lot of different things. It's kind of like being back in school, because you have everything from classroom training to laboratory training to all other kinds of things of training. They have to learn to be able to fly. They have to learn about all the systems aboard the space station. They have to learn to speak Russian. They have to learn how to do spacewalks. They have to learn how to operate all the robotic manipulator arms that reach out and pick things up in space. So just their basic training is 2 years. And right now, if you came out of basic training and got assigned to an International Space Station mission, that specific training for that mission is 2.5 years. So the answer is, as quick as you can get into space from the time you walk in the door is about 4.5 years. And depending on the mission, depending on what needs to be done, it can be a little bit longer than that. So if you just had to pick a round number, how long is it trained to go into space? Just say 5 years.
Catherine asks, how many female astronauts are there?
We've been selecting women into the space program since the astronaut class of 1978. That was our first women. There were 6 women that were part of that class. And since that time, we've selected about 52 women to participate in the space program. And that's women from all backgrounds. We have women who are pilots, we have women who are scientists, women who are engineers. So we have a really strong core of astronauts with a wide variety of backgrounds, and that includes the women who are in the program.
Getting dressed in space is no easy task. The average spacesuit weighs 270 pounds, and it takes 45 minutes to put it on. But astronauts don't wear their spacesuits every day, and because there's no dirt in space, crews only have to change their regular clothes once every 3 days.
Hi, my name is Bregan and I go to Hawaii Harbor Elementary, and my question is, why do astronauts get weaker in space?
That's a good question. Well, when you're on Earth, you use a lot of muscle just to stand up and walk around. The Earth is a big, massive planet, and that mass is what creates the gravity that holds you on to the face of the planet and makes you work when you stand up from sitting and makes you work when you run. And so your muscles are very used to having to move in this gravity. When you go into space, there is not much gravity, it's microgravity, just a little bit of gravity. And your muscles don't have to work very much. And if you don't work your muscles, just like you know from exercise, if you don't work your muscles, they get weaker. So when you're in space, your muscles don't have to work even against gravity to stand up. So they get weaker. And so that's how you get weaker when you go into space. A lot of other physiological changes happen to your body as well. So muscle weakness is one of the ones that we can work on pretty easily because we have exercise equipment on space station where the astronauts can run or lift against resistance so they can keep their muscles into shape. It's also very important for keeping your bones healthy as well.
Hi, I'm Adriana, and I'm from Cynthia Mann Elementary, and my question is, why do astronauts wear suits?
Astronauts wear suits for the simple reason they need it to keep them alive. When you go into space, there is no air. The space is a vacuum, and by definition, that means there's no air. So you need to have something around you that can hold air around your body so you can have air to breathe and also have pressure on your body. Then also the spacesuit is designed so that it has different levels of protection from the harsh environment of space. Space can be either very cold or very hot, and as you orbit Earth, it changes from hot to cold. So you need to have temperature protection from the hot and cold extremes of the space environment. There are also little bits of space rocks or debris flying at very, very fast speeds, 17,500 miles per hour. 17,500 miles per hour, that's really fast. And if one of those hits you, it would put a hole in your spacesuit if you didn't have protection. And of course, that's bad. You don't want a hole in your spacesuit because your air leaks out, your oxygen leaks out. So we also have protection on the outside of the spacesuit that helps protect from a penetration from orbital debris or micrometeoroids. So those are some of the different things that the spacesuit does to protect the human from the environment of space to keep them alive. It can also move so you can do work in it, which is really important for what we want to accomplish when we go into space with humans.
Katie would like to know, how often can you go into space?
I guess you can go into space fairly routinely. We've had astronauts who have flown in space as many as 7 times, and that wasn't any particular limit. They could have gone more if there had been any reason to do so. So the astronauts can go into space quite a few times. Now, some of that depends on how long they stay when they go. If you go for, say, a 2-week mission that we do on the Space Shuttle program, that was one thing. But on the International Space Station, we have folks going up to stay a full year, so that'd be another thing. So long duration missions, you maybe not can stay quite so, do it quite so many times because there's other things you have to worry about, like radiation from the sun. You know, you can only stand so much radiation from the sun, so that drives sometimes how many times people go into space.
Hi, my name is Henry. I go to Roosevelt Elementary, and my question is, why is there gravity in Earth but not in space?
So actually there's gravity everywhere. On Earth, the mass of the Earth pulls us toward Earth, and that's what gravity is just the pull of the mass of the Earth keeping you on the face of the Earth. When you go out in space, like when you're in orbit, in low Earth orbit on the space station, really it's kind of like you're just falling around the Earth all the time. And it's like you're in an elevator that's falling, and so if you're falling at the same rate as the elevator, it feels like you're weightless.
Welcome to the Space Vehicle Mock-Up Facility here at the Johnson Space Center. Allison McIntyre, you're the chief here, and you're going to take us on a tour.
I am. Welcome. This is where the astronauts spend a lot of their time learning how to interact and operate the different space vehicles. So our first stop is here at our Soyuz mock-up. It has a small habitation module and then the capsule that actually enters the atmosphere. This is how we're getting our astronauts and the cosmonauts to and from the space station right now. It only takes a few hours to get to the space station normally. So they're on the launch pad, they launch from Baikonur, and they in about 4 orbits of the space station. So within about 6 to 8 hours, they are at the space station. So our next stop is going to be Node 2, which is where the crew lives in their sleeping quarters. So let's go in and take a look. This is one sleeping station. There are actually 4 in a circle here, but this is it. This is all the space that a crew member has.
So this is their bedroom.
This is their bedroom.
Wow.
Pretty tiny. The crew members just slip into kind of a sleeping bag, Velcro it to the wall, put a mask over their eyes, and sleep like this on the wall. No bed required.
How big is the space station as a whole?
The space station, we have our 3 laboratory modules, and then we have a couple of other modules that help us live and habitate. So it comes out at about the size of a 3 to 5 bedroom house. One of our other laboratory modules is the US laboratory module. So let's come on in. There are handrails. These are actually there in space as well. Since you don't use your legs to walk around, you actually use handrails to pull yourself around the space station. One interesting part of the US laboratory module is the robotics workstation. So this is where the astronauts can control the big robot arm, the 57-foot Canadian arm that's out on the space station. And they also do a lot of control of the cameras, the internal cameras of the space station and the external cameras. And so we have this here so that they can practice controlling their cameras and video equipment. This is Node 1. It was the first US-built module to be on the space station. And now this is where the crew eats. So this is their galley table, just like on a ship. To this side, you have probably the most important room on space station, or module on space station. It contains a toilet.
There you go.
Very important. And a lot of exercise equipment. They have a treadmill, and a weightlifting device that they use, and a bicycle, a stationary bicycle. That's about all we have time for on Space Station today, but I'd really like to thank you for coming and visiting us and seeing how astronauts train and getting a feel for how they live in space.
So now that we've had a chance to tour the International Space Station mock-up, we've come back to Mission Control. Let me introduce Bill Foster. Thank you for telling us a little bit about Mission Control.
That's my pleasure. Welcome here.
What are we seeing behind us?
Okay, this room is here to monitor the astronauts, to monitor the systems on board the space station, to work with them for their ongoing activities during the day, make sure they're safe. Basically, we're the real-time operations and control of the International Space Station. In addition, this room actually drives the space station. Our ADCO position up near the front of the room, Attitude, Determination, and Control Officer, actually sends commands that turn the space station around as necessary, that raise or lower its orbit as necessary. So all of the actual driving of the space station is done from this room.
Now, this isn't the only kind of mission control room in the building. There's another one.
We've got our older room directly above this where we controlled the Apollo missions.
And that's where we're going to go next. So now we're in the Apollo mission control room. Why was this room preserved?
This room is very historic. A little over 45 years ago in 1969, man from the planet Earth first landed on the moon, and it was controlled from right here. The first words from the surface of the moon, Houston Tranquility Base, the Eagle has landed, came to the Capcom console right over there. So this room has a lot of historical significance, not just for the U.S. space program, but for the world in general. There is it's one of our flight directors call it, this is the Cathedral of Space Flight. It represents everything that we are doing as a nation and as a world to try and explore beyond Earth's gravity.
And joining me now is Brandy Dean, here, NASA spokesperson, and you're going to show us the future.
Right, so we are standing right here in front of a mock-up of NASA's new spacecraft Orion, which is going to be what lets us send people farther than we've ever been able to go before. It can hold 2 to 6 astronauts. For a mission with 4 crew members, it could stay in space for 21 days. If you're going to go farther than that, we'd actually dock with a habitat module, so to provide more living space, because the trip to Mars is pretty long. So if no matter how good of friends you are with your crew member, you're probably going to want a little bit more elbow room than we have in Orion.
And how is this different from the International Space Station or the shuttle?
Well, the Space Station and shuttle are both amazing vehicles. Did great things with the Space Shuttle, and Space Station, of course, is still doing amazing things. But they're limited in that they could basically only fly in circles around the Earth. Orion can go a lot farther than that. We can go visit other parts of the solar system, and it'll be the first time that we've been able to do that with humans since Apollo, and we can go to places even Apollo couldn't. But you can go to nasa.gov/Orion to find out more information.
And that's our tour of the Space Vehicle Mock-Up Facility here at the Johnson Space Center. Okay, let's go back to your questions.
Hi, my name is Madison from Cynthia Mann Elementary School, and I want to know, why do people go to the moon?
Well, that's a great question, but there's also some great answers to it. Number one, for me, somebody like me, you have to explore. I mean, exploring is just something that people want to do. If I'm out in the wilderness and there's a mountain there, I want to go up on top of the mountain and see what's there. So one of the reasons we go out into space is just because there's a human need to explore. Now, on a more practical side, we learn a lot of things when we go to the moon. We learn what was the origin of the moon, where did it come from, what's it made out of, do we know how it formed and where it came from, those kinds of things. We also can look for the makeup, the composition of the moon. What's there, what could be useful, are the things there that we could use if we landed on the moon and wanted to go up to Mars, are the things on the moon that we could use. So most of it is for scientific discovery, but the big thing for me is just a need to explore.
Hi, my name is Elliot, and I go to Foothill School, and my question is, how many times does the sun rise at the space station?
Well, the space station is going around the Earth every 90 minutes. So there's a 24-hour day, and if you divide that out, it winds up to being about 16 sunrises and sunsets that the astronauts see every 24-hour day.
Sam would like to know, can you take off your space suit or boots in space?
So there are a couple different spacesuits. One is the one that you wear when you launch and land. And so when you launch, you have your spacesuit on to protect you in case the capsule depressurizes or loses its air. And so when you get to the space station, you can take that spacesuit off because you can wear basically street clothes when you're inside the space station. It's very comfortable. Now, if you're going to go outside and do a space walk, then you need to put a spacewalking spacesuit on. We call it extravehicular activity, or EVA. So extravehicular means outside of the vehicle. So you're going to go outside the vehicle and do some work. And so then you need to wear the kind of spacesuit that I work on. So that spacesuit protects you from the harsh environment of space, provides air to breathe, pressure on the body that keeps you alive, and allows you to go out and move around to do the kind of work that we need the astronauts to do when they're on space station.
My name is Zephyrin from Cynthia Mann Elementary, and my question is, what is the longest time an astronaut's been in space?
What is the longest time an astronaut's been in space? Well, the record for a single time in space is one of the Russian cosmonaut friends who was up there for about 400 days, so up there for over a year. There have been a couple of folks who've been in space without coming home for over a year. Now, we've had other astronauts who've gone to space and come back and gone to space again. So there are 2 or 3 of the American astronauts too who have been in space a total of over a year. And think about that. That's a long time in space, a long time away from your family and your friends and your pets and things like that. But on the other hand, think how cool it is to be up there, and every day you can float around and look out at the Earth and, of course, do all the work you have to do in space. But we're trying to learn, because it's going to take a long time to go to places like Mars and other planets maybe in the future. So spending a long time in space is we're getting a lot of work done, but we're also learning a lot of things, so we'll be able to go even further than just the space station.
Hi, my name is Isaiah from Cynthia Mann Elementary School. My question is it fun going up in space?
Every story I've ever heard says that it's a blast to go up in space, literally and as an experience. So every astronaut I've talked to says it's a real kick in the pants. Literally, you feel that whole shove into space when your rocket launches off the launch pad. And that ride is a lot of fun. And then just being in space, because you can float, you can move around like Superman, you can fly, you can watch the Earth go below you. They have a lot of fun when they fly in space.
Amy, before we run out of time, let me ask you a quick question. Why did you decide to become a NASA engineer?
I always liked the idea of going into space and exploring and also helping to do something that was important not just for the United States, but also for all the people on the planet, to help us all live better and appreciate our Earth and make it better, as well as going to explore other places to learn how to do that as well. And then I would like to work on spacesuits because it's something that I can go to my lab and touch every day. So people that work on rockets maybe get to see the rocket once in their career, right? And I get to go every day and touch my spacesuits, and I get to get in the spacesuits, and that's a lot of fun.
And Dwayne, if someone wants to become an astronaut, what should he or she study in school?
NASA is a scientific and engineering kind of a place to work. So in school, in elementary school and high school, it's good to emphasize your math and science degrees. When you get out of high school and go off to college and start to get an engineering degree, things like that would be interesting to NASA, math is going to be the basis for all that. So in school, emphasize your math classes, emphasize your science classes, and do well. But the other thing I'll say about the folks who come to work here, we like them to have a kind of a diverse background, do a lot of things and do them well. So get involved in outside activities, where it's school activities or community activities or those kinds of things. All of that's of interest to us when we look at applications for people who want to come to work for NASA. But stay in school and do well. That's the key thing.
I'm sorry we've run out of time. Thank you very much, Amy and Dwayne, for answering questions today.
Thank you for having me.
Had a good time. Thank you.
Thanks also to the folks here at the Johnson Space Center who helped us out today. Do you have a question for one of our future shows? You can email it or send it as a video question, recorded on your cell phone, tablet, or webcam. Or if you're an educator, we'll even lend you a camera. And if you send in a question, you and your class can win prizes. Our last prize winner was Avery in Mrs. Woodall's class at Dalton Elementary in Dalton Gardens. So to find out all about today's topic, go to the astronaut section of the Science Trek website for facts, links, lesson plans, and more. Or watch Science Trek the web show. So send in your questions, and each week, check out my blog for the latest science news for kids. You'll find it all at idahoptv.org/science-trek. We'll see you next time. Thanks for joining us here on Science Trek.
Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
If you want to learn more about this topic or watch our videos, check out the Science Trek website at idahoptv.org/science-trek.